Okay, so we really are going to just talk about how to solve inequalities, but not only rational inequalities, but we can talk about solving polynomial inequalities as well. So my first example, I have a graph up here. You don't necessarily have to draw the graph, but I want to kind of get the idea across. If you want to sketch the graph, you can. This is our last section of chapter 2, which means we're going to have a test. When do we have the test? Tuesday. Chapter 2, part 2. Because remember, we already had chapter 2, part 1.
Chapter 2's
I sketched the graph of this on the, actually I did it on the graphing calculator and then took a picture of it and put it on my graph here. This is the graph of this polynomial function. We graphed this back at the beginning of chapter 2. We could talk about the degree, we could talk about the direction that the arrows go, we could talk about the multiplicity, right? Like I could say very easily, I know there is a 0 right here at -1, and I know there's one at 3, you know, just kind of reminding us. Multiplicity of 2 is why it just comes down and touches, right? Remember all that fun stuff? You don't have to graph these, and actually on the homework, some of them say solve graphically, and I, on the directions for your homework, do not graph any of them because it's much easier to solve algebraically than graphically, especially if you don't have a graphing calculator. So when you're solving these, step 1, find your zeros, which is really easy if it's factored, right? We know it's at x equals -1 and x equals 3. But because it's an inequality, that's not the only answer, right? If you were graphing this, you'd have to think about where you're going to shade this. Are you going to shade below the graph, which means it would be shaded like through all of this? Are you going to shade above the graph, which means it would be these answers over here, right? Like you get a range of answers.
pretty sure it's right.
So what we're going to do is we're going to just check. So instead of making a graph on your homework, when you find your zeros, you're just going to make a little line. And what you're trying to figure out is where would you shade on that x-axis? Are you going to shade less than -1, in between -1 and 3, or bigger than 3, right? Plug in numbers. And the nice thing is you're just trying to see, what are we trying to see? Oh, if it's true or not, right? Oh, sorry. I told you, I haven't really slept a lot in the last few days. I'm really struggling. And so I've just been drinking a whole lot of coffee, which I don't know is the best remedy for not sleeping, because now I just feel like my brain is...
No.
If I plug -2 in here, here's what I was trying to get to. You could actually plug it in and get the answer, but what I'm really trying to do is just see if it's bigger than 0. So when I do this, I just kind of look at the signs. I don't really care about the number. I know you have calculators and you'll just type it in and get the number. But for me, when I do this, if I plug -2 in here, -2 plus 1, that's going to be a negative number. Do you agree with me on that?
Yes.
And if I plug any number in here and square it, do you agree that's always going to be a positive number?
Yes.
So if I take a negative times a positive, is that going to be bigger than 0?
Nope.
No. You see how you don't have to actually do the arithmetic? You can actually do the arithmetic. It's not a big deal, but
That's a lot better.
it's way better, right? Pick a number in between -1 and 3. You can pick any number you want. I'm going to pick 0. And if I plug 0 in here, positive, that one's always going to be a positive, which means that's going to be a positive answer, which is bigger than 0. So I can say, I'm going to shade in between there. What about on the other side of 3, if I picked 4, 4 plus 1 is positive, positive, so I'm also going to shade there. Yes? So I remember last year, and maybe chapter P of this year, you have those little shortcuts, right? Mr. McClure taught you less than means and, greater than means or. Remember that? That works really well for absolute value graphs, and it works well for quadratics. But for things that aren't quadratics, it doesn't necessarily work all the time. So you really do have to check it, because that's kind of, you wouldn't have got that if you just... And means being in the middle, or means goes in opposite directions.
Oh, you're talking about the, okay, I got you.
Right? And so when I first did this problem, Grady, you said it's going to be on the outside because it's greater than. Remember saying that?
Yeah.
That's the less than means and, greater than means or thing. But when there's more than 1 0, that doesn't work. And so you have to just be really careful on the shortcut. All right, I say just make the chart. It's a little bit of a pain, but it's not that big of a deal. No, I don't think you were right, because you said we were going to shade out here, right?
No,
Didn't you shade that?
That's not very good.
Because what we're actually doing is we're shading in here,
Yeah.
and then over here.
I used to shade the whole graph, like everything that I just wrote down.
Because we would be shading below this graph, actually, is what happened.
Well, it's greater than the x.
What I want to see, not the graph, I want to see your answers in interval notation. So pay attention to this sign, right? Because that's only greater than, do you agree that the endpoints themselves are not included? So I would say I'm going to shade from -1 to 3. That would be this section, right? Because that word from -1 to 3. And I'm actually going to skip over 3 because 3 is not included. It's a dotted line. So I'm going to say union from 3 to infinity.
We say union because it's three.
We just say union when you write more than one interval. Union is just a fancy math way of saying both of those.
We just say the line.
We're not actually graphing anything. But I'm saying if we did graph it, we would, remember with inequalities, you either shade like above the graph or below the graph? If we graphed this and shaded it, it would actually be everything below this. But we're just talking about the x solution. So that's why we're just talking about the x-axis. So we can skip this whole part on our homework, which is super great, no graphing. If you just make the number line, pick the points, plug them in, write your answer.
Harder. Like, I know that you have to plug in more, but like, will you be able to do like scroll every time though? Like, you don't have to actually plug in.
Oh yeah. Usually they're 0. Like they're always less than or greater than 0, so that makes it really nice. Maybe I might lie. There might be another one here, but most of the time it's 0. How does it get more difficult? What if I threw in a rational expression? What if there were some asymptotes in here? We also have to take that into consideration. So let's maybe write some rules out. This is the only writing you have to do. If you don't want to write it all, you don't have to. I'm going to put it on like a double page so we can kind of see this. But when you're solving a rational expression, there's an extra step to this. So step 1, we didn't have to do step 1 on the last problem because on a polynomial, there's no undefined parts. But on a rational function, you have to find any value that makes the function undefined. Maybe like a vertical asymptote. Step 2, you're going to solve the equation just like we did yesterday. Whether it be the one we just did, which is super easy to solve because it's already factored, or if it's a rational expression, you're going to multiply through by the denominator, get your answer. And then when you make your number line to check, step 3, instead of just putting your zeros on your number line, you also have to include anything that's not defined. Anything that's not in the domain, your graph would skip over. You wouldn't shade an asymptote. And then we're going to check the numbers, which means sometimes you're going to have 3 or 4 numbers on your number line, which is a whole lot of intervals to check, right? So we're just going to practice a couple of these. This is the last concept on your test. Also this morning when I got my kid out of the car to take him to daycare, I hit him in the head with the door.
Why would you?
Palm of the ear. I didn't mean to, but
Cry.
he did cry. He had a mark on his head.
Wait till like how did it happen?
Like, I got it, here's what I learned. Don't get him out of the car seat until I've opened the other door to get his stuff out. Because I have to
He
take,
runs.
he has a backpack and all this stuff. And so I get him out of the car and set him here. And then I went to open the other door, and he just started running right as I opened the door, and just, I mean, I feel like he ran into the door, but.
So you went on and you're just like, bam, just in your face like that.
No, I felt bad. So then I told the daycare person, I was like, he did not laugh. I said, no. I told the daycare person, he had the mark on his head, I hit him with the door, just so you know, we didn't have hair. She's like, oh, okay.
My mom always laughs when she hurt as an accident. Like, she smashed her brother's name door and she couldn't even like open it because she laughed too hard.
My leg got checked over the time.
Parker shut his fingers in the door of the truck when we were going to his football game one week, and it was stuck. Like, he was on one side of the truck, and we were getting out on the other side of the truck. And he shut the door, and his hand is stuck in the door, and I'm like in the back seat getting the baby out. And I'm like, his hand is stuck! And this other guy that parked next to us opened the door because he got there faster than we could.
I actually rolled my his fingers up.
You what?
Yeah, I rolled his fingers.
when my dog was a puppy, he was looking out the window and his paw hit the window up thing. I'll never forget his little head was stuck in the door. My dog was dying.
So like, when his whole head.
Like, it was just like, I mean, we didn't, we helped him, but he started crying. But,
That's so funny.
Poor thing.
I know, my poor dog. It's amazing he's still alive.
Oh, he was still alive?
It's my dog that I say is dying all the time.
As of right now, he's still alive.
He's so thin. I should take a picture and bring it in to show you how thin he is. Like, he doesn't eat. I put dry food in his bowl, and maybe 3 days later, like, I put other food in the bowl, too, and he only eats the other food. But the dry food stays in his bowl for at least 3 days. And it's just, no, he finally eats it, and then I put new in. But it used to be I gave him 2 scoops of dry food a day, which is 1 cup. And now I give him 1 scoop, which is a half a cup, and it lasts for 3 days. Like, he's just going to die of starvation because he doesn't eat it. So.
Maybe people, that doesn't say, maybe you should give him people.
Well, I
food
do.
to keep them alive.
I do.
Give him what food? They have those like.
Don't give him corn dogs.
No corn dogs. Take the stick off first. Okay. This would be great fun for people that are watching this video.
Oh shoot, I forgot this video going.
Okay, so step 1. Tell me what's undefined. Just like if you were going to graph this, you have to think about what the asymptotes are. So how do we figure out what the asymptotes or where the points are that are undefined? Set the denominator equal to 0. So I'm going to say x squared minus 4 is not allowed to equal 0. And a lot of times you can just tell by looking, right? We could add 4, take the square root. Do you agree? I could say x is not allowed to equal plus or minus 2.
Yeah.
So that's step 1. That's the extra step that people forget about. Step 2, you're just going to solve this equation just like we would have done yesterday. Forget about the inequality sign. Like, I actually change it to an equal sign so that I don't keep that inequality sign and mess up later. What would I do to solve this? Yeah, if I multiply this over to the other side, do you agree that that's just going to become x minus 1 equals 0? Which is just x equals 1. That's nice, right? Much easier than some of the ones we did yesterday.
I mean, I don't like it.
It's okay to say you like it. It's okay to like math, like my shirt over there, right? It's okay.
That's your, I thought it was a poster.
It's just a poster cut.
Why is it on the window instead of the wall?
Because my 6th hour can't stop looking out the window, and so one day I just got mad. Well, no, first they were complaining because it was slowly falling down the wall, like it's slowly falling down the window. So they're complaining about that, and then they just looked out the window at semis all the time.
Well, you could,
And so I kind of got mad and tore it off there and said I was going to cover the whole window posters, but that's as far as I got.
Record, it's only the top.
I know, I said next year I'm going to just cover the whole window and posters, and then nobody can see out.
So depressing.
It annoys me.
Maybe you should get a curtain. That's kind of normal.
That's kind of normal.
Or bring in a bed strip, like, just hang it from the ceiling.
Step 1, we did. Find what x can't be. Step 2, find the solutions. That's what we did. Step 3, take all of those answers together and put them on a number line. Kind of important that you put your numbers in order from least to greatest, because if you put 2 and then 1, that's not good. It's happened before. And then the kind of tedious part is you have to plug in numbers here in between each one of these and see what's happening. Again, the nice thing is we're just looking that it's greater than or equal to 0, so we can kind of just look at the sign of the top over the sign of the bottom and see if it gives us a positive number, or you can actually work it out. It doesn't matter. But if I pick -3, if I plug -3 in here, do you agree the top is negative?
Yes.
If I plug -3 in the bottom, positive. A negative divided by a positive is a negative, which is not going to be greater than or equal to 0. You follow me what I'm doing when I'm doing the negatives and the positives?
Yes.
I mean, you can actually work it out, but I don't like to do that. Between -2 and 1, 0.
So you're just picking.
I'm picking a number in between this interval. Any number in the interval, as long as it's in the interval. So you could pick any number smaller than -2. You can pick any number in between -2 and 1. You just have to make sure you pick one in the interval. And I'm just plugging it in to see if it works. And if I plug 0 in there, am I going to get a positive number?
Yes.
Because I'm actually going to get -1 over -4, which is a positive number, which means yes, that's going to work. What about between 1 and 2? Okay, you're going to have to go decimal or fraction. plug 1.5 in the top. 1.5 minus 1 is a positive number, yes?
Yep.
You square 1.5 and then subtract 4. Is 1.5 squared bigger than 4 or smaller than 4? Do you know? Smaller, because 2 squared is equal to 4, which means we're actually going to get a negative number. So, no, it doesn't work. And again, you have a calculator, so don't feel like you're not allowed to use a calculator on this. You know me and my weird ways of not using a calculator, though. And pick a number bigger than 2. You can pick whatever you want. You can pick 100 if you want. I just usually pick the one right next to it. So if I pick 3, that would be positive also. Yes, positive over positive. You could pick that. No. I was about to say. This is not your answer. This is the work you do to get your answer. Your answer is now take the solutions that work. Think about if you were graphing this, you would be shading everywhere that you wrote yes.
So you say like 0
So these are our answers right here.
Oh. 1
2 to infinity. But you have to be really careful on the brackets and the parentheses, okay? Since 2 and negative 2 are asymptotes, are they ever going to have a bracket around them if it's undefined there? No. So these are asymptotes. So negative 2 is going to be parenthesis negative 2. But what about 1? 1 is a solution. Because it's an equal to, 1 is a bracket. So those are just little things you have to pay attention to. If you check your audiences in the back of the book, that'll be a nice reminder if you did your parentheses or brackets correctly. And again, 2 is an asymptote. That's why when I write this, I put the slash through it to remind myself it's not included. So 2 would also be a parenthesis. Infinity is always a parenthesis. That is the answer I need to see. The number line is just like the in-between work. How do you feel about that?
How do you feel about assigning us all odd problems?
Not gonna happen. Why I like to do multiples of 3? Because every other one is odd. So you can check every other answer.
The 5, those are odd too.
They're all odd though.
I don't know if it's 10's not odd.
Yeah, you're right. That's not enough problems to do though.
Every other.
They're all odd.
That's really fun.
I know, I had son's parent-teacher conference yesterday, and she was saying how well he's doing in math. And then she found out I was a math teacher. She was like, oh, no wonder he does well in math. And I was like, I don't know that I sit and teach you math all the time. And
That's what my dad said about us. We're all good.
Is he a math teacher? Was he a math teacher?
Yeah, he taught.
But I told my husband that, and my husband said, did you tell him you're really bad at arithmetic? Like adding. I always say, I do calculus. I don't have time for adding.
What is that in the middle in between those two columns?
It's an addition sign.
Oh, okay.
I just mean, like, I'm not quick at arithmetic usually. For the longest time, I was really bad at knowing what 9 plus 6 was. Like, it was like my downfall in life because I didn't ever know what 9 plus 6 was. 15, I'm aware of it now, but I'm just saying.
I always said 14.
As a high schooler, 9 plus 6, I always was like,
I can't remember this still.
but I know now it's 15. But I'm just saying, arithmetic, maybe not my strong suit.
What's 6 plus 9?
15.
Good, anyone?
What are my excluded values in this problem?
Negative 1 is 3.
Don't forget that part. The number one mistake that happens on the test is people just solve this equation and they just forget that you're supposed to exclude the asymptotes. And so it's just one of those things you just have to remember to do. And then we're just going to solve this just like we did yesterday. So my common denominator would just be x plus 1 and x minus 3. I will say that in second grade, I did win the times test, 100 times problems, who says times anymore? 100 multiplication problems, first one done, all right, and I won a hot pink New Kids on the Block watch, and I was so proud of myself. So.
I just had I got a peanut butter ice cream.
Well, I got New Kids on the Block
I
watch.
got like a sticker, so in first grade.
And
We got good in less than a minute though.
Less than a minute. I think ours was just whoever got done first.
That's how good, like that's how much we did it every day for like a month. And it was just like 6, 4, 7, 11, 12, like go through this like
Miss Bai went to a conference on Monday about the one where they said you had to have pain in math class. Also, she learned about this little activity where you solve a problem and you get puzzle pieces, and then every time you solve another problem, you get more puzzle pieces, and your prize is you get to put your puzzle together. I was like, my kids are not going to think that's a prize. Like, they're just be like, this is stupid.
Open up a calculus store with fake money, and we get
No, that's what elementary teachers do.
I like
We don't have time for this.
that.
These are simpler than the quadratic problems that we did yesterday. Most of these work out really nicely, pretty quick to solve because it's 0 over here. So you just get 2x minus 2 equals 0. So x equals 1. Yes? What did you do?
I put x minus 1 is x.
Oh.
And then I have 4, and then I get 2.
I don't know, have you saved that for already? I have a parrot puppet that I got in first grade. I still have it. It's like this big. Parrot puppet.
And again, the annoying part of these problems is you just have to plug them in. This one's a little bit uglier to plug in because you're having to think about when you add these together, if you get a number less than 0, which means we might actually have to do a little bit of work on this one.
Wait,
Nope.
I said it can't equal negative 1.
Oh, look, why don't I have negative 1 on here? What do I even have on here?
Why do you have negative 3?
I don't know. I was just seeing if you're paying attention.
No, you weren't. You're confused.
Sometimes you just write the wrong number down. Negative 1.
So what you're saying is you're going to all the wrong numbers from Ohio.
If I pick negative 2, I'm going to actually work this out. 1 over negative 2 plus 1 is negative 1. Plus 1 over negative 2 minus 3, that's going to be a negative number also, yes?
Yeah.
If I have a negative and a negative and I add them together, that's going to definitely be a negative. Yes?
Yeah.
So I'm going to say that's true. Do you agree with that? You see how I try to do the least amount of work possible on these? Me too.
Your brain process.
I know. Oh my gosh. See, it's harder for me to actually write down what's going on in my brain because it doesn't come out right.
So what you're saying is, if we write our own number on a test, it's okay. That just happens. We're not going to get it wrong.
Right? You can use your calculator every time. I just noticed this was a negative and this was a negative. And if you add 2 negatives together, it's going to be negative. What about between negative 1 and 1? What's a good number to pick?
0.
And if I plug 0 in there, I'm going to get 1 plus negative 1/3. Is that going to be positive or negative? Positive, so that doesn't work. I'm going to pick 2 for this one, because 2 is in between 1 and 3, and I'm going to get 2 plus 1 is 1/3 plus 2 minus 3 is negative 1. So what about 1/3 plus negative 1? Is that positive or negative? Negative, so that works. Some people like to just say, well, if it's yes, like it's going to go yes, no. Sometimes that works, but sometimes it doesn't work. The very first one we did was like no, yes. So my advice is check all of them, but some people like to just say, the last one's going to be no.
Totally forgot we were trying to figure out if it was less than or equal to 0, greater than or equal to 0. Got the sign changed.
Oh, because you were doing greater. Okay, yeah, because it's less than now, right?
Yeah.
4 plus 1 is 1/5 plus 4 minus 3 is 1. That's definitely bigger than 1, so it is a no on that one. Yes?
Yes.
It is a no, yes?
Yes, no. I'm confused. Yes was the no.
Yes, it's a no. Again, if it helps you, go through and make your parentheses and brackets on this line. Negative 1 and 3 are parentheses. So this would be a parenthesis. This would be a parenthesis. But the solution is a bracket. Right? I don't know if that just makes it a mess for you, but asymptote's not included. Solution is included because it's a line underneath it. So I think the answer here would be negative infinity to negative 2 union 1 to 3. Negative 1, just kidding. I know. I would fail my test, huh?
take a test and like us grade it?
Do you know I take every test I give you?
Can
And
we
I
grade
time
that?
myself.
Can we grade that?
Well then, after you take the test.
Okay, okay.
Why do you time yourself to make sure people have answers?
It's not you give us more than
3 times.
3 times.
So it takes you
So,
about
so I don't like to give you a test that takes me longer than 13 minutes to take.
It takes you 13 minutes to take a test.
At the most.